Alrighty, yesterday we learned how to find a percent of a number without using the bar models, and we did that by changing the percent into a decimal or a fraction, depending on our preference, and then we multiplied that times the number, and that gave us the percent of the number. So today we're going to figure out why we might want to use that and then maybe add on or subtract from. So we're going to start with adding on or making things greater, and we're going to be starting with taxes and tips. And so it's important to note that a sales tax is an additional percentage of what you pay, and that money goes to the government. So it's based on the price of the purchase you are making. So the bigger the price of the purchase, the more sales tax you will pay. Tip is the same way. The more your meal costs, the more you need to tip, because your tip is going to be 15% of the meal or 20% of the meal. And so if you want to find your total with a tax or a tip on it, you need to find that percent and then add it on to the bill that you already have. So both a tax and a tip are a percentage of your purchase. And I'll do an example down here in a second. So the first thing that you're going to do, step one, is you're going to multiply the percent, and remember that's either going to be written as a fraction or decimal, so it's going to have to change form by the purchase, and that gives me the tax or tip amount. And then I'm going to, because these are increases, we're going to add that answer to our original purchase price to get the total. So for instance, if I went to eat and my bill was $30 and I wanted to leave a 20% tip, I would find 20% of 30, which is 6, and then I would go, oh, I still have to pay that 30, and now I'm going to pay $6 more for the tip, so I have a total of $36. And we did this with the bar models, and you'll remember when we do the example down here with the bar model that we could add on, or we could go back to the beginning. So that's why there's 2 down here. We can split it out. We can always show it on 1. And when I'm showing that on here, what I just did here with the bill for this family dinner was $55. And so I would say this was $55, and that's 100% of it. And I would do then 55 divided by 10 to see what I'm going to count by, and I get 5.5. So this is 0%, 10%, and 20%. This would be $0. 10% would be $5.50. 20% would be $11. So I would do the 55 plus the 11 to see that my total bill is $66. This is the decimal version, or fractional version, or calculator version, however you want to think of it, of our bar model that we just did for this problem. Now, if we liked adding on, because our amount is getting bigger, so my 100%, I'm now bigger than that with my final answer. And so another option that we had was that we could add on to the end of our bar model. So that if this is 100%, this would be 110, because each rectangle again is 10%. And I would get to 120. And right here, this would be my $55, my 100%. This would be $60.50, and then this would give me $60, and I could finish up like that. So this particular bar model would be represented with a decimal or fraction by saying that I have to pay 100% of my bill plus 20% more of my bill for the tip. So I'm really paying 120% of my bill. So I would find 120% of 30 and go right to my answer there of $36 for the example that I gave up here. So as you can see, 2 different ways to think about this problem up here and 2 different ways to think about this problem down here. As always, I do not care which one you prefer, as long as you find one that works for you and you stick with it and use it and you feel comfortable with it. And if you want to change at some point, you're like, oh, now I get this, I understand it, and I want to add on to that and do the one-step version, that's totally fine as well. I just want you to feel really comfortable with your conceptual understanding of what percentages are. And if you can't find one that works for you, if none of them are making sense, that's when you need to come see me and we'll sit down and we'll figure something out, because there are lots of other ways to explain these. So our next example down here, it says the sales tax is 6.5%. If you buy a television for $500, what will your total price be? And so the method that we're going to see here is the method that we used up here, where we found the percentage and then added it on. And if at any time you're like, yeah, Mrs. Williams, I think I got this, feel free to pause it, try them all out, and then go back and check them. No reason to sit here and listen to me if you feel like you know what you're doing. The sales tax is 6.5%. So 6.5% of 500 tells me I'm going to multiply times 500. I have to turn that 6.5% either into a fraction or into a decimal. So if you feel comfortable turning it into a decimal, it's kind of a funky looking decimal. I've got 6%, and then I've got another half of a percent. So 6% and then another half of that percent times 500. Which gives me $32.50. If I had done it in the fraction form, I would have gotten 6.5 over 100. And you're like, Mrs. Williams, there's a decimal in that fraction. For the way we're using this fraction right now, it is okay to leave that in decimal form, even though it's not necessarily in simplest form, because it does have a decimal in it. Because I'm just going to turn around and I'm going to multiply it times 500 to get my answer. Now, because we're doing the two-step method, once I found this is my bill for my TV, and then my tax is $32.50, and I need to add those together to find my actual total for my TV. So that is my total price, including tax, because I've added it on. Once again, feel free to stop, pause here, go back, and try it on your own. So with this next question, I need to find a tax that was 7%, so my bill is increasing, which is what happens here in the second part. But first I have to find that 7%, and when I do that, I get $4.20, which is $64.20. If you want to think of this where I only have the one step, I would think of this as 107%, or 1.07 times 60, and that's still going to give me my $64.20. It's not going to tell me my tax amount on that middle step. It's just going to give me a total. Go ahead, I want you to pause and do the next problem. Make sure that you realize that you're ordering for you and your friend, that there are two people eating at this restaurant. Alrighty, so down here, we need to realize that we were ordering a hamburger meal and a drink, but we weren't just ordering it for one person. We were ordering it for two people. Oh, the distributive property. And we figure out that our bill before tax is $22.50. When the 6.5% sales tax, I want 6.5% of that original subtotal, sometimes you might hear it called. So I write that percent as a decimal. I multiply and I get $1.46 as my tax. So this is my tax. And so if I have the original bill or subtotal plus my tax, it gives me my total that I'm going to have to pay in order to get my food. Now on the back, we're doing something very similar, only this time instead of increasing, we are decreasing because we are doing a discount. A discount is a percentage off of a price that you don't have to pay. And when you find that amount that you have to pay with the discount, we call that the sale price. That's after the discount has been applied. So if it asks you to find the sale price, that means what are you actually going to pay with it on sale. So the first step is to change the percent to a, and this right here is going to be decimal or fraction, depending upon your preference, and then we are going to multiply by the original number. Now that's going to find you the amount of savings. That is not your new price. That is the amount of money that you are saving. So once I find that, that's my discount in dollars. So my discount in percent might be 20%, but my discount in dollars might be $6, which means I need to turn around and subtract that from the original price to get the new price. Now, if I have multiple discounts, it's important to know that I will need to repeat these steps, only each time I will start from my new reduced total, and then I can't combine those percents. When I'm finding percents like we did yesterday, where he takes 10% of his income and he invests it and he puts 20% towards his mortgage, they're going back and they're referring to that original total, 10% of his earnings, 20% of his earnings. If we're talking about repeated coupons, if you have multiple coupons, and if you watch the Goldbergs, you know that Beverly Goldberg is a major couponer and will do coupon after coupon after coupon. When they do that, they don't combine them. We're going to do a project next week so you can see why. But they don't combine them. They take one and then they take the next one. Or if you have a coupon, they take the coupon off and then they go back and add on the tax. So our other method of doing this deduction is that I can find the percent that I'm actually paying. So for instance, in that top one, I might find 20% of 30, find out that that is 6, and then have to do 30 minus 6 to get that my answer is 24. If I know that it's 20% off, that means I'm actually paying 80% of the original price. So instead of multiplying by 20 and then subtracting, I just have to multiply by that new percent. So I'm going to change that percent to a fraction or decimal. And multiply. I can spell it after writing it so many times today. Now, my subtraction has taken place, but it's just 100 minus 20 to get me to the 80. Whereas up here, I get a number that might be weird depending on the problem. It might be like $6.37 or something like that, and I have to subtract it from $9.84. So it might be kind of funky to look at, which, 100 minus 20, boom, boom, lots of zeros, easy to do. Still the same thing, though. I have to repeat all those steps if there are multiple discounts. So in this one, I would just do 0.80 times 30, and that automatically is going to give me the 24, and I know my sale price without having to subtract again. So when I look at this, and the bar model, when we talked about this, it says stereo is $90. It's been marked 20% off the original. So if it was $90 at 100%, and I take 20% off, one way we looked at this was we said I took off 10%. Then we took off another 10% to get 80. We said 90 divided by 10 tells me that 10% is $9. So then I just count backwards, and there's my answer. The other way you can think about this, again, is I can find 20%, and then I can subtract that. Got ahead of myself there. And I would still end up with the same answer of $72. This next one right here, it says sale price of a CD marked at 30% that cost $15 originally. If I use method 1, I'm going to find 30% of 15. Which is $4.50. And then I'm going to have to go, I'm not paying $4.50. I have to do $15 minus $4.50. And I find out that I'm paying $10.50. Method 2, I'm going to go, oh, well, if it's 30% off, that means I'm paying 70% of the price. So I just do 70 as a percent, so 0.7 times 15, and I get $10.50. So I still get the same price. It is just how my brain works and wraps around it. Doesn't matter, you pick. So right now I'm going to pause it. You should pause it. When I turn it back on, you'll see. So for these last three, the first one I did method 1 like it told me to. I found the 7% and then I added it on. The next one I knew was 25% off, so I used method 2 and found just 75% of it. So in one step I found my sale price. And in the last one I did method 1 again. I found 15%, which was $45. that was my amount of discount in dollars, and so I found out that James is going to pay $255.